Hello, my name is Rachel. Today I will be presenting my Chemistry Honors Final Deliverable. We were asked to choose and research a chemical reaction that we would later balance and analyze. I have chosen the combustion reaction of propane. The chemical formula for propane is C3H8, and below is its chemical equation. This reaction is commonly used inside and outside the home. The combustion of propane is and can be used in grills and many fireplaces. The reaction is used to help start a fire that will, in most cases, later serve some sort of purpose. This reaction is not found in living organisms as it would literally cause the organism to explode. The combustion of propane is made up of reactants and products. Within the reactants, the starting materials of the reaction, there is propane and oxygen. Propane, C3H8, is usually a gas but can be compressed into a liquid. It is used not only in grills and fireplaces but also indoor heaters and portable stoves. Oxygen, O2, is also a clear gas. It is what is floating in the air all around us and is what we inhale every day. The products, or the chemical substances produced from the reaction, are made up of carbon dioxide and water. Carbon dioxide, CO2, is a clear gas that can be used to carbonate waters and sodas. Water, H2O, a clear liquid, is used all around the world. We shower with it, we drink it, and it's in the ocean, and rain is made out of it. It's literally everywhere. The next thing we will go over is the balancing of this equation. It happens to be that the equation of the combustion of propane is already balanced, but I will show and explain to you why. What we need in order to make an equation balanced is to have all of the elements with the same amount of atoms on each side. The reason we need this is because of the law of conservation of mass. It states that mass cannot be created or destroyed, and this means that if we were to go through a reaction, we cannot spontaneously gain or lose matter. That would be defying the law. There needs to be the same amount of elements before and after the reaction. So the first step would be to count the number of atoms on each element on each side. Then we would write it under the equation and make sure that the letters are in the same order so it doesn't get confusing. For example, we have C here, and then C here, and then H, and then H, and then O, and then O. That way it's the same across each line. After we count up the amount of elements on both sides, if they are not the same, we can add coefficients, which are these numbers that are in front of the chemical formulas. We would multiply the coefficient with a subscript, which is the little number in between each element, and multiply the subscript by the coefficient, and continue until the elements have evened out on both sides. The last thing we are going to go over is how to find the limiting reactant. The limiting reactant is the chemical that constrains the reaction, meaning that there is not enough of it to produce as much as the other chemical needs. So for this problem, let's say that there are 12 moles of C3H8 propane and 8 moles of O2 oxygen. How do we find the limiting reactant? I will show you. The first step is to create a table so that we can stay organized and see everything that we're writing down. So the first thing that we need to do is put one of the compounds into this box right here. So I'm just going to choose either I'm either going to choose the propane or the oxygen. So again, I'm either going to choose the 12 moles of propane or the 8 moles of O2. In this case, I'm going to choose the 12 moles of propane. So we write that in this upper box because it'll help us later with our organization. And then in this box down here, we are also going to write something about propane. We're going to write how many moles of propane are in the actual equation. So if we remember back to the equation, which is C3H8 plus 5O2, these are the reactants. We can see that there's no subscript or there's no mole number, so we can just put 1 mole of C3H8. Then in this top box right here, we're going to do a very similar thing, but because we didn't choose O2 before, we chose propane for the upper left box. We are going to put mole in this middle box. So what we're going to do, we're going to put O2 in the middle box. So we put however many moles there actually are in the equation, and we can see that there are 5 right here. 5 moles, or the coefficient number 5. So we'll do 5 moles of O2. And the next step is what we're going to do is we're going to multiply these two so that, so then we get 60. So 12 times 5 equals 60. And then we divide by this bottom number here, 1. So divided by 1, that's still 60. So this answer is going right up here, and we're going to get 60 moles of O2. Now, before we had 12 moles of propane and 8 moles of O2 from our word problem on the slide before. But because so basically what this table is showing is that for every 12 moles of propane, we need 60 moles of O2. And from the previous problem, we only had 8 moles of O2. And so O2 would be the limiting reactant because there's not enough to fulfill what the 12 moles of propane needs. So because it limits everything, it's limiting how much propane we can use, it's limiting the amount the reaction can make, things like that. So in the end, it would be O2 would be our limiting reactant, or we could write it all special like this: limiting reactant equals O2. Alright guys, thank you so much for watching, and see you next time.